Quadratic Functions in Standard Form, Lesson 2, Completing the Square. This lesson will focus on converting quadratic functions from standard form to vertex form, and analyzing quadratic functions of the form y equals ax squared plus bx plus c, and writing quadratic functions to model situations. In the previous two lessons, we looked at something called standard form and something called vertex form. Vertex form has the advantage of allowing us to see A, P, and Q easily. We need to be able to convert functions from standard form to vertex form, and so we're going to use a process called completing the square. To complete the square, we use our experience with perfect trinomials to help us. So let's first of all review what a perfect trinomial is. A perfect trinomial is one where when we factor it, will give us two equal factors. So if we look at this example, using our box method, we could factor this into 1 and 1, 3 and 3, and we end up with two equal factors of x plus 3. They can be written separately or as x plus 3 squared. We want to build on that idea as we're completing the square in this example. We're going to rewrite it so that we have y equals, and then in brackets we are going to put x squared minus 8x. We're going to leave the 5 outside of the brackets right now and leave a blank inside here. We want to fill in a number in that blank that will allow us to form a perfect trinomial square inside of the brackets. To do that, that term can be found by taking the number in front of our x term, in this case 8, dividing it by 2, which gives us 4, and then squaring 4. 4 squared is 16. Now we can't just randomly add numbers in, or we're changing what our equation is. So in this case, we are adding 16 in. To keep the equation the same as the one we started with, we need to also take that 16 away again. Our next line, we are going to factor what's in the brackets. Because we've designed it to be a perfect trinomial square, it will factor into two equal factors. Those factors are going to be x. Our sign comes from the sign in front of our x term in the line above, so it's going to be minus. And the second term comes from the square root of this term that we added in. So the square root of 16 is 4. Outside of the brackets, we're going to combine these two terms. 5 take away 16 is negative 11. We now have our quadratic function in vertex form. We can compare it to the general form of vertex form, which is y equals a x minus p squared plus q. This then allows us to graph the function and find out other information from it. So for this function, we found that a was 1, p was 4, q was negative 11. We can do a quick sketch of what that graph looks like. Our vertex is located down at 4 and negative 11, so over 4, down negative 11. We can start there. We know that it opens up because our a value is 1. We're going to convert from standard form into vertex form and state our y-intercept. So let's get into into vertex form. F of x is the same thing as y, so I can rewrite this as y equals. Again, we want to include our x squared term and our x term inside of the brackets and leave our constant term outside. To find the term that's going to be added on inside of our bracket, we are going to look at the coefficient of our x term and divide it by 2. 6 divided by 2 is 3. 3 squared is 9. So we're going to add 9 in order to keep our equation equal. We need to also take that 9 away. Factoring our trinomial, we know that it will factor into 2 equal factors. X, the sign comes from the coefficient in front of our x, and the second term comes from the square root of 9, or 3. At the end, we have 5 take away 9, or negative 4. We can look at finding our vertex from this information. Our vertex is our p and q value. Remember that the p value is always the opposite, so negative 3 and negative 4 is our vertex. Our y-intercept, you will recall earlier in the lesson, or perhaps in yesterday's, we learned that the y-intercept was actually equal to the c value in standard form. So our c value in this equation is positive 5, and so our y-intercept is positive 5. I can also determine the number of x-intercepts that there are if I look at what the general shape of this parabola is. Our vertex is at negative 3 and negative 4, so it's somewhere down here. Because our a value is positive, it means that this parabola is going to open up. If I extend those arms, regardless of how wide or narrow they are, I can see that it will cross my x-axis exactly twice. So the y-intercepts, I can't find what they are at this point, but I can tell you that the number of them is 2. Let's look at an example where we have a number in front of our x squared term. So again, I'm going to rewrite this as y equals, and I want to factor out whatever number is in front of our x squared. So I'm going to take out a factor of 3 from the first 2 terms. If I take out a factor of 3, I have x squared minus 4x, and because I'm not including the 9, or the negative 9, inside the brackets, I don't need to take out the factor of 3. The next step uses the coefficient in front of the x again. 4 divided by 2 is 2. 2 squared is 4, so I'm going to add 4 in. We need to be careful at this point. In the last step, we would have subtracted 4. However, we can't do that this time. And the reason is that when we added this 4 in here, it's actually being multiplied by 3. So 3 times 4 is 12. So we've actually added 12 to that equation. To keep things equal, we then need to subtract 12. We have y equals 3. Our 2 factors from our trinomial become x minus from the coefficient in front of the x term. The square root of 4 is 2. And negative 9 take away 12 is negative 21. Again, we can find our vertex. Vertex comes from our p value, so positive 2, and our q value, negative 21. Has a y-intercept. The y-intercept is the c value when it is written in standard form. So our y-intercept this time is negative 9. And we can determine the number of x-intercepts. A quick sketch. Vertex is at positive 2 and negative 21, so way down here. Our a value is positive 3, so our parabola opens up. How many times is that parabola going to cross the x-axis? Twice. So our number of x-intercepts are 2. Another example, this one is a little bit different because our c value is missing. We're going to follow exactly the same steps. So y equals, we want to factor out the coefficient in front of our x squared, so we're going to take out a factor of negative 5. leaves us with x squared from our first term and 14, positive 14 from our second term. We have nothing outside of our bracket this time because we don't have a c value. Now the same steps as before. 14 divided by 2 is 7. So 14 divided by 2 is 7. 7 squared is 49. So I'm going to add 49 in here. Remember that I can't just add 49 on the outside because this negative 5 is being multiplied. I need to do negative 5 times 49, which is negative 245. So to keep things equal, I need to add 245. Y equals negative 5. Our factors of our trinomial are x plus 7, and we have plus 245 as our q value. So our vertex is negative 7 and 245 from the line above. Our y-intercept is our c value, but remember that we didn't have one this time, so our c value is 0. The number of x-intercepts, doing a quick sketch. Our vertex is negative 7, so over here and way up at the top. The a value is negative, so my parabola is going to open down. And so eventually we will end up with 2 x-intercepts. You may be asked to verify your solution. If I want to verify this solution, what I would like to do, verify, is to expand our answer. So we have determined that the vertex form is y equals negative 5 x plus 7 squared plus 245. So we want to work backwards. If we expand that out, we should end up with what we started with in the first place. So this becomes y equals negative 5 times x plus 7 times x plus 7 plus 245. Y equals negative 5, and then I'm going to expand my binomials first. X times x is x squared. X times 7 is plus 7x. 7 times x is plus 7x, and 7 times 7 is positive 49. I still have the plus 245 on the end. This gives me y equals negative 5 times x squared plus 14x plus 49 plus 245. Y equals, now I need to multiply this negative 5 in to my bracket to all three of those terms. So negative 5x squared minus 70x minus 245 plus 245. Last step, y equals negative 5x squared minus 70x plus 0. This is what we started with, and so I have verified my answer.